Hello, class.
Good morning.
6 people. Everybody sign the room.
Yeah. I had a question. What do we do if we forgot to sign it last week?
Normally, I could go in and sign it for you. Who is that?
That's James Stringfellow.
Wait a minute, let me turn this off. Who that?
James Stringfellow.
Springfield. Yeah, I could go in there and do that's very quick.
Thank you.
Let's see something. Springfield. And that was the 23rd. Okay, I've added you.
Thank you. I appreciate it.
All right. Let me get back to not this. Yeah. All right. Anybody have any questions? I still need to grade your assignments. That case statement, we'll look at that before we continue on with chapter 5. Hopefully everybody took the test. Let me share my screen real quick. All right. No, let's see. Let me go down to. Yeah. All right. So let's look at the case statement. The issue I was having on the case statement was that I had default, but I didn't have any statements for the default. So what I did, I emailed you a copy of this, minus, I just added the C out inline here and the C out inline here. So if you run it, if you run this program, is going to allow you to enter a letter, let you know if it's an A or B, or then it's no grade. So if I put in the letter A, here it says grade A, and then it kicks out. So what happens, we enter the letter here, letter was char, and then what it said is it's the command switch A. So it took the letter A, from letter and compared it to see if it was an A. If it was an A, I did everything within here. And notice there's a break. That's important, and it depends on what your programming is doing. So once it found out that it is the A, it will do all of this, however many statements you have, and then it'll break on out of this case statement. All right. So if it was a B, it'll check this, it will skip all of this, and then it'll fall down to here. So it's like an if statement, correct? In a sense. Now, I ran it for the A, let's run it for the B. All right, close this. Let's debug it. And let's say B. All right, see, grade is B with a new line. So it skipped this part this time and it printed this. But now, I'm gonna show you one important thing about that break statement. So here, if I'm gonna just comment it out, I could have deleted it, but I commented out, meaning that it's just a comment. It's not a statement anymore. It's not a command. So if I run this now with this, what will happen is it's gonna, if I put the letter A in, it's gonna fall into this case and it will do this case and it will continue to do this case regardless if it's true or false because it does not have a break. And so watch what happens here. If I put in the letter A and hit enter, see, it says what? Grade is A, grade is B. Because this command here was commented, it didn't allow for you to break out of that situation. Now, then, well, let me show you. I could take it out of all of them. Let's do this. Let's do this. So, let's do this. I'll take that break out. I'll take this break out. And okay, I don't have a break in it. So if I do this and I run it, what you think will print out when I run this time? So I don't have any breaks in the program, in this section. So, and I put the letter A. It'll perform this. There's no break. It's gonna do what? Perform this. There's no break. So it should what? Perform this also. So if I put the letter A, look, it performed each one of these conditions, which is what? Not correct. So you got to make sure that you put in the breaks. Now, sometimes you may not want to put a break in certain places. Give you an example. If and like I said, if this program was written to where I had an array or a string of characters, and I wanted to count all of the A's, whether uppercase or lowercase. So therefore, what I can do is something like this. I would say, okay, I would do this, and then I would say case. Right. All right. And like I say, so now I can leave this here, or I could move. I'll say I move this. I'll still need. I'll leave it at that and copy this. Or not. I'll just. I think I need some kind of condition, some kind of statement. But let me cut this and paste this here. All right. So it's going to do case A, lowercase a, grade is A. So I don't think I should get an error. So I debug this and watch what happens. Let's say. So now, okay, it's right here. So now if I put a lowercase a, see, grade is A. So it's like I don't have to check. I don't have to worry about uppercase and lowercase because I have the case statement checking for upper and lower. I don't need to put a break, check for uppercase A, then break A, then break lowercase a, unless I wanted to have them distinctly identified. So sometimes you may want to put the break, but notice the break was put before the letter what? B. Okay, so that's how the case statement works. And like I say, it could be as long as you want. You can check for every alphabet. You can check for whatever. All right. So rather than use an if, remember we said you could use a case rather than use the if statement. All right. And even with the case statement, you can remember how we kind of did functions. If I had a function set up, I could call that function. If I was calling header, I could call a function within that case section. I call a function here. So like I say, it makes your program a little cleaner than using if statements, and all those different levels. But some choose to use ifs, some choose to use cases. It's just programmer style. All right. So I just wanted to go over that to show you how the case statements work. Any questions?
So just to be clear, whether you put in the capital A or the lowercase a, it's going to give you those both relate to the
To this code here, correct? Right. So like if I was like I said, well, we're getting in the loops. I could have something where I could say it A equals 0. Right. And so down here somewhere I can say A is equal to A plus 1, or A plus plus, we'll get into that, A plus 1. So every time, if I was in a loop going through it over and over, a string of characters, every time it hit a capital A or lowercase a, it'll add 1 to the variable A. So when I print out this variable here, I could call it A count or count A. I'll just say, because you could count A, okay, and I'll make this, well, you're not. All right, so what happens is it'll count it, every time it hit it, it'll increment, and what happens is now I can print out the count of the number of A's I found, whether uppercase or lowercase, in that string or whatever. All right, so that's how it works. All right, so this would test for both cases, and it will perform this whether it's an A or whether it's a lowercase. But if I had a break in here and did something, then this would be only for the uppercase A, and this would be only for the lowercase a with the break. Okay, any other questions?
If you do that, count A plus 1, where does it give you that count at, like when you run it?
What you mean give it to you? Output it or
if it was the count, the A's, right? So you had 5 A's.
Right.
Where's it going to give you that number at?
Where it's going to give you the 5 at?
Yeah.
Well, after you complete it, well, you could output every time you increment right here, say C out A, increment, output the number. Or once it completes this statement here, or this case, then outside of this, then you can output the values of count A.
Okay, I got you.
You understand?
Yes,
but what also happened, you would have to maybe have a loop, something, like, and we're going to get into that eventually, today. Like if I say, while, I'll say letter not equal to a period. Say I was reading in a sentence. So as it read every character, it's going, well, let me do it like it's supposed to be done. You do this. And you would have to have some other things going on, because I have to have it as an array where there would be a string of characters, and then I'll have to increment, and I'm getting into something that's different. Increment the array value where we're moving forward to each character in the string. And as we go through it, we're checking to see if it's an A. If it's an A, we increment, we do whatever. But then once we get outside, once we get the tally, then we can do a C out count A. You understand?
Yes, sir.
All right. So I could output it here, like I said, or I could output it each time I increment it, whatever my logic, is to be doing. All right. Any questions? Any other questions? But we're about to get into loops in a little while. Well, right after we do this, and we'll see what I'm talking about with loops. All right. Any questions? Okay. So now, if I let me go back to the notes. Go to the notes. All right. So now we're going to talk about the repetition structure, or that's the loops. All right. What that means is now we're going to start we write code where we can branch off. Right. That was dealing with the decision. Now we're dealing with repetitive execution of certain code. Now, what that does is I can execute a particular code multiple times, as many times as my condition holds true or whatever, based upon what I'm doing. So now, the introduction to repetition structure. All right. So it says a repetition structure causes a statement or a set of statements, because it could be one statement or it could be multiple statements. All right. To execute repeatedly so many times. It can do it for a limited number of time, which is a control repetition, or you can do it based upon a situation or based upon a condition, so that would be more or less where it's not controlled, all right? So programmers commonly have to write code that performs the same task over and over, all right? It says, for example, suppose you have been asked to write a program that calculates a 10% sales commission for several sales people, okay? Although it would not be a good design, one could approach, approach would be to write the code to calculate one person's commission, and then repeat the code for each person. All right, so what they're saying is this, I'm gonna close this out. They're saying what we can do is, I think that's yeah. Okay, and I'll take this off. What they're saying is this: we've written code to where we inputted some values, right? So let's take a number. Let's make this int. I'll say ints, and I'll say we're gonna do cost or salary. All right, we'll say int salary. All right, and then we can say, okay, we want to write the code to give that person 10% of their salary. All right, so we could do see out enter type enter salary, all right, and CN salary, all right. Now, should I do a name? Should I do a name? Should I do a name? Okay, I'll do the name. Okay, and then I'll do all right, do name. Okay, so see out. We'll do name. If I do get line, we know we could do more a double name, but just get line. Okay. Then we'll do what CN name. All right. Okay. So now we input the name, we input a salary. So now what we'll do and I'll just do the see out. I'll do the calculation. Normally just gross. All right, and we just doing the 10%. So we'll just do something like gross is equal to salary times 1.1. Now, this 1.1, if we say we're giving them 10%, we're doing the 1, which is whatever their salary is, plus the 0.1, which is the 10%. So it's doing it all at one time, rather than finding the 10%, adding it to it, and then whatever. So those are some of the tricks or whatever that you can do, whatever. But you can break it down to where you're doing it step by step. But the 1.1 does everything together. And then I can say, see out. I'll do both. I didn't do set with. I'll just do name. And then name, and I don't have set with, and this would be salary. I'll just do growth. I won't do the salary. I'll do the growth. But I could have done the salary also. All right. Okay. So now, we wrote this program, and what will this program do? This program will execute, giving us what? Enter a name, okay, enter a salary, and then they're going to multiply it to 1.1, and then they're going to output the name and then what the gross is. All right. So let's run this. Okay, I think I got all the errors out. I think I'm to the okay. Yeah, that should be good. Okay, let's run it. See if we got any errors. Okay, so enter name. All right, I'll say John. Look what I did. Okay, I'll just say John Doe. Okay, and in a salary, I'll say $1,200. So look what happens. It printed out John Doe, and it printed out the salary plus 10%. Okay, so now let's let me do this. Now, what if I wanted to input 5 different people, all right? And I wanted to calculate and do whatever. So now I'll show you with a loop. I could say while, all right? And I could say X is less than 5. All right. But what I'd have to do is I would have to set X. I'll say int X equals, and we'll go over this, but I'm just showing you now. And I'll put this here. What I want to do while X is less than 5. So what happens is now, while X is less than 5, we want to do all of this. Right? So what happens? I'm going to input one person's information. It's going to perform this. But, well, then I have to increment X because otherwise X will stay at 0. Then I can do X plus plus. Now, this is increment X by 1. All right. This is a shortcut with C++ where you can say, rather than you can say X equal X plus 1, you can just do X plus plus. All right, so we'll look at that too later on. So now, X is 0, all right? The first time through, X is 0. While 0 is less than 5. Is 0 less than 5? Yes, it performs this. It comes back because this is the block that is performing. It comes back, well, then it increment X by 1. So what? 0 plus 1 is equal to 1. So now X is equal to 1. Is 1 less than 5? Yes. So now it's going to perform this what? A second time. Okay, it performs this, and then it increment X by 1. 1 plus 1 equals 2. So it's going to go back here. Is 2 less than 5? Yes. So now it's going to perform it a third time. All right, perform this, increment by 1, 2, equals 2 plus 1. 2 plus 1 is 3. Is 3 less than 5? Yes. So to perform it the 4th time. So it performs this. It's going to do 3 is equal to 3 plus 1. So that's equal to 4. Is 4 less than 5? Yes. So it performs this the 5th time. So it performs this. Is in the 4 is equal to 4 plus 1. So X becomes 5. Is 5 less than 5? No, 5 is equal to 5. So now it kicks out and the program ends. Questions? All right. Anybody?
I did have one question that's kind of related to it. So you say, you can set it to where they can run it 5 times, right?
Right.
But so you as the programmer want them to be able to run it 5 times, but what if the user only wanted to enter 4 people? Is there a way to put like a skip to end button kind of thing?
Well, this is what this is. There's something called a sentinel. All right. And what we can do, and well, let's run this one, then I'll do what you're talking about. All right. So let's do this one 5 times because we know we want to do it 5 times. All right. And this probably wouldn't be the loop you would use, but let's do it. I'll say John 1. I'll just say John 1. So the first time through, I'll say 300. See, it gave him the 10%. Okay. No. But you see, I don't know if we did this in this class. It's going from name to number. So what I have to do in here, I have to do a, right before I input the name again, I have to do a cn.ignore to clear out my buffer. So, because before I go back and read the next one. So debug it, I have to debug it again because it didn't give me an opportunity to put the name. All right, so now I run it. John 1. Okay, I'll do 1. Okay, salary 300. Okay, it output John 1. Now it asking me what? In a name. I'll say John 2. Type. And then put 450. It give me the 10%. Next one, John 3. It increments it. And then John 4. All right. And 500, 5%, 10%. And John 5. All right. And then I hit enter and I'll put whatever and see it ended, correct? So it did 5, 1, 2, 3, 4, 5, and it ended. Now, Mr. Who that was?
James.
Okay, Mr. Springfellow. That's it, right?
Yes, sir. You good.
All right. So now I think he asked about, okay, well, what if the user didn't want to put 5, they wanted to put 4, you've written the program. Okay. Now, what you can do is something called a sentinel. It's a value that, and like I say, a value that's not really being used for anything but to trigger something. Okay. So what I can do here is put while, and I could use X, while, but I'm gonna have to kind of change the program up a little bit. All right. So I'll say while X not equal to, and I could say 9999999. All right, so that would be a value, and I could put I'll say -99. All right, so well, say negative 999 because that's not really a salary, right? A negative number. A person either worked and got from 0 or didn't work, got 0 or above, correct? So a negative 999. I could have put -1 or whatever, but I just chose the negative 999. So while X is not equal to 999, do this. But now, how many times will I perform this, class?
With that, it would be 999 times, right?
No. I'll change this to 0. So how many times will it perform this loop? It says what? While X what?
Well, X is not equal, so
All right. So how many times did it perform it? Or when will it stop? When will it stop performing it?
1,000, maybe?
No. When X is equal to a negative 999. So as long as the user, and see what I'm gonna have to do here, I'm gonna have to do something like say, let's see, see out, I'll change this to see out, and do this to continue. Well, let's see, to exit. Type negative 999. All right. So
Okay, I see now. So basically, it'll go on as long as the user wants it.
right, you got me. So if I wanted to do one, it'll just do one. If I wanted 20, it'll allow me to do up until what? I type in that what? That negative 999. Right. Right? Okay. So I'll do C out, but then I need to do what? I need to space this and semicolon, then I'll do CN X, right? Because I'm reading in X. I'll do that right. All right. Now, so let's run it. So that should give it to me. I think I have it correct. Okay. So see how your logic all of a sudden now is not just straight, do this, do this, do this, do this, do this. Now we understand we can do, okay, do this, if this, do this, do this. But now we got what? Do this, if this, do this, while whatever, do whatever, then continue on and do. So it's like we building on our skills, and these are all of most of the principles of coding. All right, your loops, your decisions, and then your sequential statements. All right, that's the principle of most coding. All right, so let's debug this. All right. So now it say enter name. So I'll say John 1, hit enter, salary, whatever. Now it says type in negative 999, okay, or to exit to 99 or otherwise any number. So I'll put in 3. See, enter name. So I'll put John 2, all right, and then a salary, hit enter. Now I put in negative 999, right? See, program ended, right? So it's like that allows you to control, unlimited. So you don't know the number, but the user can what? Or the user is guided to what? Hey, if you want to enter a number, hey, just type in this value. It's going to take you back to the loop. Okay. If you want to enter another or repeat this process, enter any number, process the loop. If you want to exit though, type in 999 and you're finished. Right? Everybody see that? Questions? Anybody with questions? All right. So now let's talk about our loops. All right. We kind of talked about, okay, what a loop is, whatever. How we kind of looked at this, the duplication of code, because this is what loops avoid you from doing. If I didn't have a loop, I'll take this out. All right. So if I had this, all right, and I wanted to perform this 5 times, I would have to what? Copy this, and then what? Paste. Right. So that's 2 times. You understand? So look how many lines of code I have already. All right. Paste. All right. That's 3. Paste. That's 4. And paste. That's 5. So you see what happens here? All of a sudden, I have all these lines, and the code is what? Duplicated, correct? The code is being duplicated. So why not what? Create the code, and then what? Just loop through that code as many times as you need to, and it what? It reduces the amount of code you may have in your program that to execute. And like I say, when you create this program here and you compile it, this one will run slower than the previous one because what? You have more lines of code in this program. All right. The less number of lines, the less memory being used, and the more faster it can load in your computer's memory, and the quicker it can run. Now, these are small programs, but like if you get in a habit of coding in that fashion where you're limiting the number of lines of code and being more efficient, then you can write code that can run a lot faster. All right. So if I run this, It's gonna run exactly the same as the very first time. It's gonna run it like John, and I ain't gonna go all the way through. I'm gonna do one John 1 salary. All right. Oh, I left that in, but that doesn't matter because I could hear that. That doesn't matter. I left that in, but I put the letter A. I need to take that out because that doesn't matter anymore because we're not doing we're not in the loop. All right, remember that? We're not in our loop. So this could come up. We did that when we had our loop, where we're asking them to input a value to continue or to exit. But we're not doing that anymore. Not here. All right. Okay, all right. So now let's run it. All right, debug it. All right. So we run it. Okay, John 1. Okay, John 2. John 3. John 4. Well, I did 3. I did 3 twice. And John 5. See? And it ended. So the exact same code, you know what I'm saying? It's exact same process. But what? When we did the loop, we reduced the code considerably. All right? So any questions? Questions. So that's one of the advantages of using loops. All right? One of the advantages. So it says, and we looked at it, it says here, as you can see, all right, this is a long sequence structure containing a lot of duplicate code, which was what? The code we just did ourselves. What we did 5 times. We did that same exact code 5 times. So that's all it is. It's just a long sequence of statements that just go straight down. Just keep doing whatever. Okay. Now, and a lot of the code is duplicated. All right. There are several disadvantages to this approach, which are, duplicate code makes programs larger. All right. So what happens? Now your programs get larger and larger. Because what? If we had to change our code to where we was inputting 100 salesman's information rather than 5, then all of a sudden now our program is that much larger. All right. Well, we got to copy and paste. So it would make it large. Then writing a long sequence of statements can be time consuming. And like I say, what you can do, you can mess up like I did. Well, I had add code in there that was part of the loop, but I had to go what? I had to go in every piece of copied text and take it out, right? So if I had copied that 100 times and then I left something in that I didn't need, I have to go back 100 times and remove it, all right? So it says if part of the code part of the duplicated code has to be corrected, which I just did, or changed, then the corrections or change has to be done that many times. All right. So those are some of the disadvantages of just trying to write the code in sequential form without trying to write loops. Okay. And it says instead of writing the same sequence of statements over and over, a better way is to repeatedly perform an operation to write a code for the operation once. All right. So, and then place that code in a structure that makes the computer repeat it as many times as necessary. And that will be called a loop. All right. Okay. This is done with the repetition structure. Now, so we have conditions, controls, and count control loops. Now, we did the condition control loops, which is what? The while loop. Meaning what? If that condition hold true, we performing this. But there's a count control loop. Now, what I'll do, I'll show you that count control, but then we'll go back, we'll go in the notes and do it. Now, remember, let me take this out, starting here. All right. So what we did the first time, we did a condition control, meaning based upon the value of X, whatever that user put in for X, that set of statements was executed. Now let's do a count control. That means you can use it's a for statement, and it has a certain format, and it's like for. Now I could introduce a value, or I could use a variable, or I could use a variable. All right. Say we're going to use I, so I could do for int. All right, so I'm introducing a new variable, int I equals 0, and starting at 0, I less than 5, semicolon, I plus plus. Now, by default, it will only do this one 5 times if I don't group it. Remember I said about the body with the if statement? The very next statement is the default statement. So if I don't need to put curly braces, but based on my logic here, I want to execute all this based on this condition. So what I would do is I'd have to put curly brace here and curly brace here, because based on this condition, I want to perform all of this. Otherwise, it would have just outputted inner name, inner name, inner name, inner name, inner name, inner name 5 times, and then it'll ask me for to input the name, and then input a salary, and then they're gonna give me 1 salary. But the name, inner name, would have been outputted 5 times by default. All right. So now, if you look at this, the breakdown, the for statement, okay, I'm introducing a variable for int I equals 0. Okay, the I starting at 0, and I going to be incremented by 1, I plus plus, until I is while I is less than 5. When I becomes equal to or greater than 5, it's going to kick out. Now you say, well, Mr. Vessel, why you ask if it's going to be equal to or greater than? Because in my code here, I could increment I could reassign the value of I, where I could say I equal 100. So if it does this one time and I was changed to 100, when it comes back here, it's going to say, okay, I is 100 greater than 5, less than 5? No, and it kicks out. So you got to be careful. So if you change the value yourself, it can cause you to not run the loop as many times as you want. So let's run this. So it's going to perform this 5 times. When I'm going to perform this, and here we go. Okay, John 1, whatever. Okay, John 2, John 3, John 4, John 5. I put in a mark. But look, so notice, same code, well, not the exact same code, but the same body, pretty much, with what? A for statement. You understand what I'm saying? So now you can say, well, if I use the count, then I'm pretty much in the same situation as when I want to just do 2. That is correct. So you can't use this one to say, okay, do it until a number is hit. You can't do that. All right, you'd have to use the other while. Okay, I mean, you have to use the while or the do. You can't use the for, because the for is controlled, where it says, okay, do it so many times. All right. Now, but like I say, it allows you to perform it. Now, the beauty about this is sometimes you do know, depending on what it is, what type of code you're writing, you do know how many times you want to perform this. And then what? You might say, oh, wow, I need to change this to 500. No problem. All you do is change that number here, and now it's going to perform 500 times. You understand? So that's one of the beauties of using the loops, and you can set, the values without having to try to copy code X number of times. All right. So now let's look at what it's talking about here. All right. So it says, well, let's see, you got the conditional control, which we talked about, the while and the do. We didn't look at the do yet. We'll look at it later. And then the count control, which is the for. All right. So it says a condition control loop uses true false conditions to control the number of times that it repeats. While X is less than 5, true or false. If it's true, it performs it. So that's conditional. Count control loops repeat a specific number of times. For X less than 5, okay, X is 0. Do the sequence. Of statements. Okay, increment. Is it less than? Do it again. Is it less than? Do it again. So it's gonna do it until it reaches that particular number and it kicks out. Okay, so those are the two. So now we're talking about the condition control loops. The while, we looked at what the while does. Now you have the do while and the do until. These two are very similar. What happens is it says the do until causes a statement or statements to repeat until the condition is true. All right. Whereas the while, you performing the true condition already. All right. So you can say while X is less than 5, true, do it. All right, that's the do. But then until, you might have do this until X is equal to, or X is greater than 5. So see, it's like kind of just asking a different question. It's not equal to 5, true, do that. And then you're gonna increment till it gets to reach 5 and then kicks out. All right. So those while loops are similar. So the while loop, and it just give me the diagram. The while loop gets its name from the way it works. The while is a condition, while the condition is true, do some task. So what we had, while X is less than 5, perform whatever statements we had to perform, go back and we'll increment and then check. Perform, increment, check. Okay, perform, increment and then check. Perform, increment, and check. So you're doing that. As long as the condition is true, you're performing that. Otherwise, you're doing the false and exiting out. Let me show you something what happens with students sometimes. And I'm talking about like when you have a large program. All right, you might have something like, say, while X is less than 10. All right. All right, so you say, well, I'll just say 5. While X is less than 5, and then we want to increment, okay. X plus. So say we, X is 100. What will the output of this program be, class? Anybody?
It wouldn't run it, right?
It would run the program, but what would the output be? You're on the right track. You said it wouldn't run it. That means it'll get an error. You won't get an error, but it will do what?
Well, it'll just open the program and then basically end, right?
Right, correct. There you go. Right. Yeah. So it wouldn't run it, but you wouldn't get any output. So what? Because what? It says X is equal to 100. But then here you're saying, while X is less than 5. Is 100 less than 5? No. So it's going to go down here and just end the program. Everybody see that? So sometimes, and like I said, when you start writing large programs and complex programs, you're gonna have to be able to go through your program and know what values are for what variables throughout the program, because you might have a simple problem made complex just because you don't know the value, but you saying, oh, I want to do this 5 times. I'm gonna just take that value and I'm gonna put it in here, make it do it 5 times. But this value is something great because this statement could be what? 500 lines away from this or something. You understand? So let's debug it and watch what happens. And it just gonna give us the see what I'm saying? It just give us nothing because it did not execute those statements because it did not fall as being true. All right. And now I'm gonna show you another thing. And what I'll do, I'll take this out this time and I'll just say, I'm gonna just output something. All right, I'll leave the, yeah, I'll just do the X plus plus. All right. So I'll do like see out while loop. So I'm gonna print out while loop. All right. So this will allow me to, well, not this. If I set this to 0, all right, and I'll print out X. Let me print out X. And, all right, so looking at this, X is 0, X less than 5, output that increment. So this is gonna output how many times? How many times is gonna output loop what? 5 times. So if I debug this, it's gonna show me, well, where is it? Okay, there we go. So look, the first time through is 0. Next time through 1. Next time through 2, 3, and 4. So what? 0, 1, 2, 3, 4. That's 1, 2, 3, 4, 5. Right? Now, you might say, well, Mr. Sylvester, why start at 0? You know, you're going 0 to 4. Why not start at 1? Hey, you can do 1, but if I do 1 here, what am I have to change in my program for this to do 5 times?
You're gonna have to make it less than equal to.
Less than or equal to, or what I can do what?
You could change it
Less
to
than
less than 6.
Correct, less than 6. So see how some of the ways you can write the code. Your code might say less than 6. Another person's code might say less than or equal to 5. They both correct, right? So it's just that, you know, how a person thinks, you know. Neither one is wrong, but they're gonna still do it what? 5 times, right? So I'll say less than or equal to 5. All right. So now let's run this. The only difference here is it's going to go 1, 2, 3, 4, 5, right? See here? Now, I can't say for sure, well, not say that, but starting at 0. Why would you think sometimes it would be a good practice to say start at 0 and do less than 5? And we never really gotten to it yet. But the computer start counts at what? 0. You know, we as humans, we take 0 as being insignificant, but it's really not. But the computer starts at 0. We start at 1. Now, when you're gonna start coding and having to deal with subscripts, which we're dealing with arrays or vectors, etc., you're gonna understand that, wait a minute, in order for me to grab the first position of a string or first position of an array or first element of a vector, I have to start at 0. You understand? So that's why we really should understand them counts. 0 to 5, 0 to less than 5 is 5. All right. And now I know if I have a string that I need to implement or check, and it's 5 or less, or 5, I can go from 0 less than 5, and I'll pick up the first position in the computer up to the 5th position. Right. So that's why a good practice to start at 0 and increment to whatever. But like I say, you don't have to, because looping 5 times is looping 5 times. All right. But when you start referencing certain like I say, arrays and whatnot, it's going to become important that you start at the 0. Now, if I look at this, I say, I want to perform this 50 times. All I need to do is change this, right? Less than 50. So see how easy that is rather than me try to type while loop 50 times? You understand? So it did that loop what? 50 times by me just simply going in and putting 50. All right. So, but you got to understand what happens. The while loop, you got your initialization of your variable, right? Where X is 0. You got your condition where X is less than 50. Okay, so that's your test condition. But then you have your increment, right? Now, remember our for loop? Remember we had what? For int I equals 0, our starting point, our initialization, I less than 5, or it could be 50, and then I plus plus, that's your increment. So see how the format is different, but you have some of the same elements in it? The initialization, the test condition, and then the increment and the increment, all right? So even though they're not set up the same way, in theory, they practically work and use the same principles to do what it needs to do. All right. So now, so that's the while loop. So it's in a while loop. Before you can fall into the while loop, your condition has to be what? True. All right. So that's one important thing about the while loop. You cannot write code for a while loop. Remember we said this, that we put 100 here. It will never perform this. So you would not execute that set of statements. All right. It will never perform this. It'll just run the program and give you the ending. All right. So in order for the while loop body to be executed, this has to be true. Right. This has to give you a true result. X less than 50. No, X is 100. They're going to kick out return 0. So that's one important thing. Now, so it tells us right here, all right, make sure that the while clause and the end while clause are aligned. Or they're just trying to make sure that your body is indented and it's able to be read right, because you can run into issues if this stuff is not aligned and whatever, and now you're trying to figure out, or you might do something like this. That's good. That's correct. But sometimes it makes it hard to know what's all entailed. All this is correct, right? But and like I say, it's all programmers' preference. But to me, this says, okay, this is the body for this while. This is what it does. Okay, let's move on. But like I said, you don't have to code in that fashion. All right. So and then it just makes it look more perfect. So let's look at this. We wrote a program, so we don't really have to look at this part. Okay, while keep going. Now what we did while what? Well, we said what? If to continue type in any number, otherwise than negative 999 in the program. So what they did, they put a while and they put a choice for yes or no. So now look, keep going, yes or no. So there's many different ways you can write your code to what? To cater to the end user. Because what happens? In order to write it in this fashion, all right, all you would do is something like this. Okay, you'll have while loop, and this could be whatever. If you wanted to perform a certain number of times, you could do something like this, char letter. All right, okay. And then you could say, I could say equal y. And I'll do lower k. All right. Then you could say while equals y. All right. So now what? Now I'm not entering a number. I'm in I need to put single quotes. Okay, and y. Okay. Then what? I'll do something like this. See how and then I don't need this x anymore. take this X off. Okay. Then I can say C out enter. If I can tell you Y to continue. Now I can stop here, say enter Y to continue, but then I could be more specific and say any other key. To exit. So the user knows, okay, if I hit anything other than Y, then I know it's gonna exit. All right. So I'll put the space here, semicolon, and then CN Y. All right. So now what happens here? Same difference. Okay, it's Y. All right. It's gonna print while loop. Enter Y to continue. Okay, any other key to exit. So what I do? Not supposed to be not Y, that's supposed to be letter class. My fault. So CN letter. All right. I got this backward. All right. So CN letter. So when you CN letter, it's gonna go back up here, check to see if it's Y. If it's Y, it's gonna continue. If not, it's gonna exit. So watch this, debug it, and hopefully all the errors are out. The first time through, it's gonna automatically do it. All right. So now if I put Y, see, Y, as long as I put Y, it's gonna perform that loop. I don't care how many times I put Y, I can sit there all day and night and put Y, it's gonna perform that loop. But then if I put anything other than Y, Y. What did I do? It should have exited. Let's see. Wow. Oh, class. What was the one mistake I did?
You need to have two equal signs.
Right. I didn't do the comparison equal. I did the assignment equal, which automatically what? No matter what I typed in, is setting it equal to that value, which makes it what? True. All right. So that's one of the issues. All right. And that was the issue in this program. All right. So that's the issue. So debug it. All right. Okay, now I'll put the Y again, and notice that that's working fine. So now I can put any other character, I'll put in a 3, and it should exit. All right, so see how that equal sign is very important. And you, like I say, you got thousands of lines of code, and you have this mistake in it, and you running your program, oh, I got it, it's working, it's whatever. And maybe a day, a week, a month down the line, the company is running the code and it's not doing what it's supposed to do. And now you got to go back and check to see what's going on with your code. All right. So you see how I made that mistake with that one equal sign. But that's how you can perform it where I say, well, I'll keep it going. I did something where what? Enter Y to continue. So that's all it did. So, and what? It had to equal a Y to fall in the loop. If I didn't set it equal to Y before it got there, it would not have performed it, okay? It would not perform it. And like I say, you could have asked the question before you got into the loop. You could have said something like, if you know you was performing sales commission, you could have a prompt that says, you know, where you chose the sales commission, say routine or function, and then you'd have a prompt. Are you sure you want to continue to the sales commission routine? All right. Well, you have like a if out here. Well, it'll be an if. If is equal to Y, okay, then fall in here and it'll go ahead on and do it. So, and that's just some control features that when you're writing code that you can do. All right. So, if we look at this, look at the code. If keep going, look at this. All this is sequence, is what? Statement after statement after statement after statement after statement. So that in turn is sequence. When they perform this, but this is what? That loop structure. So you do all this, you come back, you check to see if it's Y, you do it all over again, check to see if it's Y, do it all over again until what? Until it's any other key. When it's not Y, then it's gonna end the program. All right. So The while loop is a pretest. All that's saying is you have to be, the value has to hold true, or the condition has to hold true in order for you to perform this. So that's why it's telling you that this has to be true in order for it to perform this. So it is a pretest, just to see if it's true. Oh, it's true. Now perform that information. So that's all it's saying, all it's meaning on that part. All right. Now, that's another program dealing with temperature, too high, too low. And then another one dealing with the loop. All right. So, and what? It asking you to input a temperature. So what happens is you got your declarations and everything above. Okay, if temperature is greater than max temp, if it is, you're doing all this. Temperature too high, do whatever, do something else, and then input another temperature. Input another temperature is going back, asking that temperature is greater. If it is, going back, do whatever. But if it's not, oh, temperature's fine, whatever, check back in 15 minutes. All right. So, and how would I say it? When you're on the computer, there's many things that you have a loop. How many people have and I know you've done it when you even sign the roll or whatever. When you logging in with a login and password, when you type in that login, all right, sometimes it'll tell you, oh, it's not found. And then it prompts you what? Back to input the login information. Oh, wrong. It prompts you again. Now the password, what they do is for security purposes, they may give you one attempt and then clear the screen and then bring you back to another app. Sometimes they'll give you 3 attempts. You type it in, oh, wrong password, re-enter. Wrong password, re-enter. And after the 3rd one, they may kick you out because they don't want you to constantly try to keep inputting the password. That's how pretty much hackers, get into systems. If they have multiple attempts to do something, they normally can write code and run some script to try to figure out the password. But if they kick them out every time and they have to come back in, it makes it harder. They don't try to bother with that. But a lot of times you're in loops when you do that. Like I say, enter the password. Oh, incorrect, re-enter. That's a loop. It allows you to do it multiple times. Now, that infinite loop. What is an infinite loop? An infinite loop is a loop that, based on your logic, will never end. All right. The computer looks at it and know that the logic will never end. All right. Give me an example. Let's go back to this program. Let me go back somewhere. I had the 50 and 100. Okay, take this. All right. All right. So we had this. Okay, don't worry. I don't need to worry about that. All right. I'm gonna put this back. So now, say we have this, right? And what if I do this? Okay. X is 0, right? Okay, while X is less than 5. Well, I could change this to 2. Less than 2. How many times, looking at this, how many times will it perform this loop? Anybody? How many times will it perform this loop? Huh?
2 times.
2 times. You say, well, I'm not sure, Mr. Investor. You just writing that. Yeah. Okay, let's look at it. I clicked the wrong thing. All right, so let's look at it and see how many times. 2 times, 0 and 1, right? If I change this to minus. Now, X plus plus add 1 each time. X minus subtract 1. So how many times you think it's gonna perform this code here? Now.
It'll be infinite. It won't stop.
Correct, because rather than going up the number line, Now we go into what? The negative side. So anything on the negative side of zero, of the number line from zero going negative, will never be greater than 2, correct? So that's why now, if I try to debug this, and different compilers and operating systems work differently. Some time out, some of them will sit there and just continue and run it. It just depends on the operating system. So look what happened. You see what's happening? It's giving me what X value is. So see how fast it's actually running it? It's all the way to 80,000 now. I mean, 8,000 already, right? So it done went through that loop that many times already. So but it'll never reach 2 because it's going the opposite way. So this loop is just a continuous loop. And that can be a headache in a program also. You know, you're running a program and you know you're supposed to get maybe just 2 lines of code, 2 lines of output. And then all of a sudden they're just spitting out the same thing throughout the whole, all over a page or whatever. You're like, what's happening? What's going on? 9 times out of 10, if it's some of the same information or whatever, it's an infinite loop, all right? So see, it'll just continue. Now I have to use some system interrupt, such as a control C or a break or whatever to exit out of this loop, all right? Now, some operating systems or some compilers, what they'll do is say, okay, this program is running, but I don't see where it's gonna ever exit out or do whatever. So what it says is, I'm gonna time it out because it's just stuck on this. So it times out and it says like program abort. Okay, so depending on the operating system you're on, you'll get it to in an infinitely loop or it will abort. Now, if I hit Control C, see it exit out. Now that has nothing to do with the program. That has everything to do with the operating system. The operating system has control mechanisms to kick out of a program that is stuck, you know, in a loop or whatnot. Or like say, a lot of times when you program, a lot of times if you working with something and something is constantly running on your system, you do Control C, West Windows, you do Control C and it'll exit out. All right. So now let's go back to got a few more minutes, man. So that's the infinite loop. That's what happened with an infinite loop. Now, modularizing the code in the body of a loop. All right. So modules can be called from the statements in the body of a loop. That's no problem. Watch. And matter of fact, it's good. So if I'll take this information, all right, and what I'm gonna do, I'll change that. I'll copy this. And I'll just leave it as a global variable. Okay, I'm gonna paste this, I'm gonna change this to plus plus. I have to give it a function heading. I'll just call it that. All right. And do this. And do this. All right, so that's my now I need to say here void. Okay. Well, I need to take X off. I'm gonna take X and make it. I'm gonna make X global because I'm not gonna pass it. Okay, but normally you wanna pass your variables. Okay, I'm gonna do this loop. So now X can be recognized here and there without me passing it, but I could have passed it. So now I'll take this out and now I'll do LLOOP. All right. So now what? Now in here, what? Every time it executes this, it's gonna perform this. So what? I can call those statements. I could create a loop, not a loop. I can create a function and call that function as many times as I want to. So now when I do a debug on this, it's gonna do it 2 times still. See what I'm saying? So what it did. So what happens is, I'm gonna move this to the side. What happened is, okay, X is equal to 0. Or is it equal to 0? Yeah, X is equal to 0. It's global. It says while X is less than 2, okay, 0 is less than 2, yes. I want to execute this function. What I want to do, output this output while loop and X value, which is 0. I want to increment X by 1. X becomes 1. So go back up here, back to this statement here, go to the end of this, go back, it goes back to here. Okay, 1 less than 2, yes. Perform this loop. So go down here, call that loop. It calls this, print out while loop, X becomes 1. Well, here, X becomes 1. And then, well, X is already 1. X becomes 2. And then it goes back to the end of here, okay. It's 2 less than 2, nope. And then it hit the return 0 and it ends. So see how you can do functions. You can call functions, no problem. You don't have any problems with that. That'll work too. So that'll relieve you from having to what? Put all kind of code in this loop. Hey, just call whatever and let it loop. Because you might have another function that need to call that same line of code. All right. So that's all they're saying about that. All right, here your function, show commission. So if keep it going is Y, call this function called show commission. All right, once you finish, all right, display, do you want to do another one? If you type yes, input, keep it going. All right, and then what? It goes back, perform the function again. And if it's Y, if it's Y, you perform this function, call it, and then ask if you want to do another one. So see, and this is the actual function. This is show commission, and this is the show commission function and what it's actually doing. All right, and your return takes you back to the program where it ends here. All right, well, at the end of the function. All right, this return takes you back to the next statement after the function. Now, the do while loop, it's time too. The do while loop, what it does, it executes the statements and then come back and then it checks. Now, I'll show you that right quick, then we'll go. Man, so what the do while does is this. I know what I'll take this out and cut this. I'll paste this here and the do. And what happens is with the do, you got to have a semicolon at the end. So I've just taken a while loop and made it into a do, okay? Rather than have while in your condition here with no semicolon, you'll have do, and then at the very end of your body, you'll have while and whatever the condition is, semicolon. Now, you say, well, Mr. Vester, if you can do it this way or that way, why do it, why have those two ways of doing it? Well, with the while loop, remember, the condition had to be true to fall inside. With the do, you will perform the body of the do at least one time. You don't have to, your condition don't have to be true. So what happens is, looking at this, I could set X to be 100. If I set X to be 100, it's going to say do. So no matter what the value of X is, it's not going to test it until what? The end of the while loop, of the do while. Everybody understand that? That's one of the big differences. It's going to check it at the end of the do. So it will perform this at least one time. So let's run it. Let's do the debug. You say, well, you say it's going to perform at least one time. Oh, see? So then it gives the value of 100. So X is 100, but it says do this. But if I go back and put that while here, then what happens, and take the semicolon off, then it will not perform this, it'll just exit, all right? So if I set this to 0, it's still gonna do it 2 times, because what? When it's 0, it's gonna perform this, all right? And the 0 less than, well, okay, well, it's gonna increment by 1 down here. Is one less than, yes, it's gonna do it. Then it's gonna increment to 2, 2 less than 0. All right, so watch. Let's debug it. Down here. See here? It still did it the 2 times. But no matter what the value is for X, it will at least perform it 1 time. A lot of times programmers use the do when they displaying a menu. You know, like when you're doing something like choose A, B, C, or D, and like a menu, A to add, or B to perform this, C to perform this. So you want the menu to show first, and then based on what the value is, you may return back and display it again, or you know whatnot. But that's what the do pretty much helps you to do. Display the information at least 1 time, or execute the information at least 1 time. All right. So any questions? Because we got to that. Any questions? Anybody? Hello?
No, sir.
All right. So when we come back on next class period, we'll continue with our section, our chapter. All right. So like I said, just read up on the chapters so that you can kind of know what's going on, and so we can continue on with our loops. All right. Now, if we look at let's see if I have it. Let's see. Oh, what did I do? Oh, here we go. All right, so we go to modules. I don't think I have a quiz in this section, so no. They got and or. We looked at and or already. Right. So because in these programs, we'll get to the next chapter, and then I'll post these. All right. And all this showing you where I wanted you to write a loop to input values and then get a total. And we'll look at that on next class period. And I'll post them. I'll give you assignments. Well, class, next week is spring break, right?
Yes, sir.
Do we have, okay, yeah, next week we won't have. So what I can do, I'll post this so you can look at them if you choose to. All right. So I'll post these. And if you look at it, what happens is one of them, all 3 programs do the exact same thing. But one of them is a while loop. Well, let's go back. I think I'll go back one. One of them is a for loop. One of them is a while loop, all right? And then the other one is the do while loop, all right? So I'm just trying to get you to know the difference in doing it. Doing the same exact code, same exact algorithm, all right? All you're doing is inputting 3 numbers and then getting the total and printing out the total, but using 3 different type of loops, all right? So I'll post these. They'll be there, but they won't be due until, or even not next week, and not the next week, because the next week we'll be coming back. So I'm gonna just post them. I'll put a date on it, but the date ain't gonna be the date. I'll tell you what the date is. It'll be the next class period. All right. It'll be not next class, which is off. Not next class period, but the next. Wow, that's 3 weeks. Whoa, we're close to that. So this is. Let's look at this. So this is spring break. They won't be due here. They will be due here on the 20th. And then the next class period, we have our chapter 6. Right, that's good. Chapter 6. Yeah. Okay. So I'll put the due date as the 20th. But like I say, we'll meet on this date, and hopefully you have enough information on how to do them and understand them. And like I say, you can ask questions, you know, when we get in class, so that you can continue and finish it. All right. So I'll set that up, and like I say, you can look at them, and like I say, read up on your chapter. All right. All right, class.
Yes, sir. Thank you.
All right. Have a good one.
Sir.
All right.
Mr. Sylvester,
Yeah.
on BRC's website, it has you listed, I think, as an advisor. Should I just email you? Because I just wanted to go over somebody, because I'm going for associates for computer science. I just want to go over like
Okay, what's your name?
James Stringfellow.
Okay, we could go. We could look at it. Don't let's. We could go over
Just
it
want-
now.
yeah,
Like right quick, if you got
yeah,
time.
yeah, I got time. I got about
Okay.
30 minutes to my next class. So
All right. Yeah. Yeah. Me too. Let me see something.
let me just open up my
Right. And you made this computer science, huh?
yes, sir. I'm
Yeah.
going for
The
associate.
A. Okay. Yeah. Yeah.
But what I'm trying to do is I'm trying to make sure that I'll be able to transfer once I get my AS to a
Where you
university.
to where?
I'm not sure yet where I'm gonna go, so I want to be able to have my options open.
Okay.
Before
Yeah. See, and that sometimes that's an issue because
yeah,
certain schools that we have agreements with, you know, they want you to take certain classes.
like
Yeah.
what would you recommend? Because I'm looking to probably go into cybersecurity, right?
Now the cybersecurity, we don't have an AS in cybersecurity.
No,
We're gonna have a AAS,
yeah,
right?
but you guys have
But
like the computer science, and then
right now, what I would say is get the AS because because if you go into a 4-year institution for your cybersecurity degree, you're gonna have to. Well, not all of them. You might not need all the classes. Yeah, see, and it depends on the school you go to.
yeah,
But it depends because a 4-year institute might want you to take all those programming classes and whatever, you know.
yeah.
Yeah, so it might work for you, you know. But I never looked at
Like
it.
my
Yeah.
plan was I'm wanting to get eventually my bachelor's in computer science and then just taking, some cybersecurity electives. Because you could either get,
Right,
with
certified, yeah.
cybersecurity, you could get
Right,
a degree in cybersecurity, or you could do it in computer science, which is the
right,
broader, subject. So I was going to do the broad subject of computer science and then just get like the CompTIA
right.
certification.
Yeah, go take those certifications, yeah.
Yeah.
Well, yeah, you can do that too. Yeah, because listen, your computer science degree will always come in handy, man.
Yeah.
It's gonna always because it's like what I said.
But I
The
mean,
world of computers intertwines so much, you know. It does, and then it intertwines so much that what you can specialize in something, but if you're already in the computer science field, you can easily
yeah.
transition, right? So
Well,
that yeah.
that's kind of what I was thinking. I wanted to learn, the basics of everything,
Right.
right? And that's why I wanted to go for the computer science degree,
Right.
just going for a cybersecurity. You know
Right.
what I mean? Uh,
Right. And like I say, and you might get into that, oh, I don't want cybersecurity, I want
yeah,
system programming, or I want
true.
something else, network or whatever it is. But
It's another thing.
you have the
Don't change
foundation,
my
you have
mind,
that
bro.
AS. Right.
Definitely possible to change my mind, but
Right.
so as far as like what I have, hold on one sec. Uh, what I have signed up for next semester, I just want to make sure I'm
All
signed
right.
up for the correct things. I've got let's see, where did it go?
You looking at do you see my screen?
Yes, sir.
Yeah. So I'm thinking you should have English 2.
Yes,
You
yes.
should have CSCI 193.
Let me see. Classes. I already signed up for classes next semester. I just wanted to.
Right, that's what I'm saying. But
Yeah,
are those some of the classes?
yeah. I'm just pulling it up now. It's loading.
Okay.
Exact,
Yeah,
exact ones.
right.
Okay, so right now I have let's see, I have oh, I'm looking at the wrong one. I'm looking at spring, not fall.
Oh yeah.
Okay, I got fall. Okay, so I'm currently math 1213.
Okay, that's the algebra.
Yeah, college algebra.
Okay, yeah. See now, I'm gonna show you something. to get the computer science degree, those
Yeah.
those classes are prerequisites to get the calculus.
Yeah.
So they don't. Okay, so you got that. They don't count. Okay.
I gotta do that class, and I think
Entry.
trade, yeah.
Right.
And then I can take calculus 1, right?
Right. Correct.
Because I'm actually in math, like the pre-college algebra math right now.
Okay. Right. Okay.
Because I got my GED back when I was like 16.
Okay.
10
Yeah.
years ago. So
Right.
I took it's called like the developmental and prereq classes.
Right. Ain't no problem. Yeah.
Yeah, I mean, you know, I needed it, right?
Right. To kind of help, because otherwise you'd have got into those other classes after take it 2 or 3 times.
Yeah.
Yeah. That's right.
All right. So English Comp 102.
Right.
And then I signed up for general biology, which is bio 1013. I think it said that was required somewhere.
Right, it required. You got the lab?
I didn't sign up for the lab as well. Do I have to sign up for the lab as well?
Yeah, you got to take the for general biology 1 and 1 lab, biology 2 and 2 lab. Yeah, you need those labs.
Do I have to take the lab like side by side with it in the same?
It's best because it coincides. Okay. Otherwise, you'll take biology, and then when you take the lab, you wouldn't be taking the leg, which is comparable to what you're doing in the lab. You know what I'm saying? Yeah, but you don't have to. You don't have to, but it makes it a little harder.
That's one of the things I wasn't sure about, like if I should take the lab.
Take the lab. Take the lab. Take the lab with that biology 1 and biology 1 lab. That's right. So you got. Go ahead.
Got visual arts.
Hold up. Visual arts. Let's see something.
Yeah.
Visual arts. I don't see that.
1023.
Visual arts.
Yeah. I wasn't sure if that's the one I was supposed to take. And that's why.
Who said that?
When you go to like under Lola, they have this degree works dashboard, right?
Yeah.
And when I went to that, if I pull that up right quick, it showed me that, let me let it load up so I can tell you what it says.
But that's not the only elective art elective it showed you, huh?
No, it was let me just, okay, I got it pulled up. I'm just looking for it. It's natural science. Let's see.
I would take one of these courses that's listed on here.
Okay.
Yeah. That gonna transfer, Now that one might, but these are the classes we normally see and accept, and we know that they're gonna carry over.
You just look for it, see what it says. Science lab. And now it's making it difficult to find all of a sudden. Okay, fine arts requirement. It says to choose one of the fine arts requirement, but now it's minimized. Okay.